Number 11. A class of 180 students, 48 are taking the math, 38 are taking physics, 51 are taking both, and one student is picked at random. Find the following. So it looks like 43 of them are not, so we're just going to do some basic math here. Finding the probability of not taking math, so pretty much get rid of these guys here. Since 51 are taking both and 48 are only taking, we're going to take 180. We're going to get rid of the 48 that are only taking math and the 51 that are taking both math and physics. So that leaves us with 81. And that's 81. Now, the reason why I can do that, though, I'm not including 43 here, is because I'm starting with the entire universe there. That's 180 students there. And I'm getting rid of the 40. Yeah, so that's okay. I'm including this number in here in case you were wondering. All right, so the probability would be 81 out of 180. So actually 9 will go into both of those. 9 out of 20. So we are looking at, 45%. Or just leave it 9 over 20. That's okay. 45% picked at random, not taking math. That gels with me, okay? 38 are not taking math here, but taking physics. 43 are taking neither of them. So in fact, neither would be 43 out of 180. Okay, now let's just get that percentage. And again, you could leave it as a fraction. That's actually pretty preferred in the probability community. Here we got 23.9%. Okay, not taking math, but not physics. So it looks like it's just 48 out of that group. And so you'll see this is pretty basic math. It's just knowing how to read that chart, how to read a Venn diagram. Venn diagrams are actually really, really important in some advanced mathematics. It's really how mathematicians convey complex ideas. So I'm recording, right? Yeah, good. How they can convey complex ideas. So it's not just numbers like that. They'll be like sets of like collections of objects, and it can get pretty hard to wrap it in your head. So they'll do a Venn diagram. Tom has 15 coins in his pocket, consists of 2 quarters, 4 dimes, 4 nickels, 5 pennies. He takes out 1 coin at a time and does not put any coins back into his pocket, so no repeating. What is the probability that the first 2 coins he takes will be nickels? Okay, so these are dependent events because the second event is dependent on the first one. So the first coin, for it to be a nickel, there's 4 of them, and he said that there were 15 coins. Okay, the probability that the first 2 coins will be nickels. So 4 out of 15 there. Then you've already got 1, so you're not putting it back. So now you have 14 nickels in the bag or in his pocket, and now there's 3 of them. Okay, so this guy just needs to be multiplied. We're going to get 12 at the top here over 15 times 14, 210. Okay, 12 out of 210 is 0.0571. Okay, that's the probability. So about 6%. What is the probability that the coins are a quarter and a dime? Okay, so let's think. We draw a quarter. So that would be, for that first slot, it's 2 out of 15. Okay, now when you go to the next one, there's still 4 dimes in the bag, but you have diminished by 1 coin. So that's how this changes up. Okay, you got 2 out of 15 coins, and now you got 4 dimes in the second slot, but you've actually already taken 1 of those coins out of the bag, so there's actually 14 left. So you got 8 out of 15 times 14 is 210, which we already figured that out. So what is that, 4 out of 105? All right, we're looking at, again, like close to 3%, 3.8%. Okay, and if you want to leave it as a fraction, that's still okay. Refer to the card shown below. Each probably, what if there's no replacement for all of this? Okay, so let's see. What is the probability that after you, what's the probability of M and then an A? Okay, well, to draw an M, got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and there's 2 out of 12 M's. Okay, so you've grabbed one of them. Okay, and then to choose an A would be 1, 2, 3, and then it's 3 out of 11. So notice the dependent situations here. Okay, these are dependent. I just noticed my computer screen went a little faint, so I have to charge it ASAP or all is lost. Okay, there we go. All right, and so that was 3 out of 11, so that's 6 out of 12, which is 132, and you can just leave that like that. Okay, so next, M, then an M. So you get 2 out of 12, but then you're going to multiply by, since you grabbed 1, you did not replace, no replacement. You're down to M, but you're also down to 1. You've already taken 1. So now you're 2 out of 132, which is 1 out of 66. Okay. You can figure out that percentage, but it's small. All right. Okay, here's the last guys here. MP3 player has a playlist of 12 songs. You select the shuffle option. How many different orders can the songs be played? Now, how many different orders kind of gives that one away, that it would be a permutation, because it would be the order matters. Okay, if you switch the order of songs 1 and 2, then you've got a different playlist. So what's 12 choose 2? So 12, let's go alpha, and it is 7. 12 choose, not 12 choose 2, 12 choose 12. Okay, and we got, it's a lot, 479 million, 1,600. It's hard to imagine, but when order counts, it's a big deal. It's a big deal. An entry code consists of 1 digit followed by 2 letters. Okay, the number 0 and the letter O are not used. How many codes are possible if the letters can be repeated? So an entry code consists of 1 digit. So the 1 digit we don't have to worry about repeating. We will use 1 through, here I'm just going to circle 9 there. Got 9 possibilities for the 1 digit. Now we got 2 letters, okay, but the letter O is not used. So that means then that, here, let me think here. 9 possibilities. So that means I've got 25 possibilities for my first letter because the O has been taken out of the mix. So next though, I can't have a repeat of the one before, so now I've got 24 letters to deal with for the second letter. Now I only have a digit and 2 letters. Okay, so the reason why this is 25 instead of 26 is because we are short O. Okay, that's a total of 5,400. Teacher plans to send 4 students to the computer lab each day. There are 25 students in the class. How many ways can the teacher choose 4 student groups to go to the computer lab on the first day? Okay, now the order doesn't count here. She does have 25 students, so that's going to be a combination. So here we go. Combination is 8. And I got 25, and I'm choosing 4. It's probably, yep, large number, 12,650. All right. The PIN code for an internet consists of 5 digits. You must choose a 1 or 2 for the first digit. Okay, so that's 2 choices. How many, you must choose that for, how many different codes are possible? Okay, so looks like it was just the first digit that needed to be a 1 or a 2. Everything else could be 0 to 9. Okay, so that means then 1 or 2 for this guy. And then right there, we got 10 digits for the last 4. That's going to be 10,000 times 2 is 20,000. So notice that this is the fundamental counting principle type of problem and not a combination or a permutation. Florida license plate consists of 3 letters and 3 digits. How many different license plates are possible? We did this problem together. It doesn't say that license plates can't duplicate their letters, so you could have a AAA. So we got 26 possibilities there, and then we got 10 possibilities for each of the 3 digits, and that's it. So 26 times 26 times 26 times 10 to the 3rd power. And we got 17,576,000. Yeah, we definitely did this problem together because we talked about we had enough plates for the state of Michigan, and absolutely we do. Alex is on an 8-day vacation. He plans to spend 1 day surfing, 1 day golfing, 1 day at the amusement park. How many ways can Alex schedule the 3 activities? Now, scheduling, order is important. So this is a permutation. And he's got 8 days. Now let's think about this for a second. Alex schedule the 3 activities. Order counts. 8-day vacation. And okay, is it a permutation? I just want to make sure it's a permutation in my brain. The order is going to count, and it can go in any of those slots. 8 choosing 3. Yeah. 8 choosing 3. Okay. All right. I was overthinking. So permutation, 8 choosing 3. 336 different ways to schedule those events. The Spirit Club is making posters for the basketball team. They are using poster boards in the school, colors of teal, gray, black, and white. They also have markers in teal, black, and white. Markers. How many different posters can be made using 1 poster board and 2 different markers? Using poster boards and the colors of. Okay, so how many different posters? Well, that would be 1, 2, 3, 4 different posters, and then we're going to have 2 different markers. So if we've got 1, 2, 3. Okay, how about we do this? Why don't we look at it a different way? 4, choose 1 for the poster. And then in the second piece, you're going to have 1, 2, 3. And of the 3 of the markers, you choose 2. Okay, so here's the combinations for the posters. Here's the combinations for the markers. Okay, now 4 choose 1, I believe, is 4. I don't. I'm running on fumes here. Times. Did you want to watch something tonight, Laura? 12 different ways. I want to watch Endor. People are going crazy about Endor. Lessons in chemistry. What is the probability that a random selected... I got 2 more problems. What is the probability that a random selected date in 1 year is not in the months of June, July, or August? Well, there's 365 days in a year. Okay. And let's think. We want to get rid of all of the months of June. or all the days in June. So that would get us out of, that's 30 days there. We got to get rid of July, and we got to get rid of the August days. So let's get rid of those just to see how many days are left after we get rid of these. Now notice that this is a different type of problem. Okay, so that's 273 days left out of the year if I subtracted those days. Okay, so you can leave it like this, or 273 divided by 365 is got 75% chance, which makes sense because, well, that's 3/4 of the year, right? But it's just, you know, the July and August just have an extra day, so it's not quite perfectly 75%. It's slightly under. Secretary has 5 different forms that need to be mailed in 5 different envelopes. What is the probability that all 5 forms are placed in the correct envelope? Okay. So well, you got 5 forms, 5 envelopes, that's 25 options. So to make them perfect, you'd have to have just the 1 in 25 shot of it being in the correct envelope, which 1 in 25, that's 4%. Okay. All right. That's it.